Hello and welcome. I'm James Mooney and I'm from the Bodleian Libraries. Today I'll be talking about our digital preservation microservices project. To give you a bit of background, the Bodleian Libraries hold a lot of digital collections of long-term value. These include digitized images, which are openly available through our service called Digital Bodleian. We also have closed images from our commercial digitization arm. We also have university publications, research data, which we call Aura and Aura Data. We also have digital born archives and digitized books. So our project needed to monitor around about 300 terabytes of storage, which was about 58 million files. These are used on Linux and Windows servers, and so they connect with CIF and NFS. Back in 2017, we carried out one-off ad hoc scans of this data using open source tools, but what we found was it was really difficult to understand how those repositories were changing with those tools. In 2018, we then reviewed all the existing end-to-end digital preservation systems, but for a variety of reasons, we decided not to go with any of those. They weren't going to work for us for a number of reasons. And so in 2019, we made the business case to create our own digital preservation, microservices, and reporting tool. This wouldn't require us to move any of our content from our existing repositories, which we were quite happy with, and it would act as an independent, proactive system, providing digital preservation actions to what we already had. So our DPMS system was born. And yes, it's another animal in digital preservation. This time, a hippo. If anyone remembers the game Hungry Hippos, we felt this was a good representation of our microservices gathering up all the data from the core repositories. So when we were developing the microservices within the system, we created them as 6 individual deployments. This allowed us to develop a service, deploy it into production, and then move on to the next deployment. And so far, we've developed 4 of the 6 deployments. So that's file integrity, virus checking, backup and restore analysis, and characterization. And so we're currently working on validation and then look to complete the preservation copy analysis service. So the approach we took for all of this project was that it was going to operate independently from each of the repository's application layers. It was going to access the files directly on the file systems, and we were going to try and use as much existing infrastructure wherever possible, and overall try and keep it really simple. So we use a number of open source software to achieve this. We use a product called Rundeck, which does the automation of tasks and the microservices. We use Elasticstack for indexing all the data. We use Zabbix for monitoring the statistics, Grafana for the visualization of the data, and we use GitLab for issue tracking within the service owner's repositories. So I'll provide a quick overview of the architecture of how the service works. Again, we have to go quite quickly. We haven't got time to go into detail. But basically, we have a virtual machine that runs Rundeck, and that schedules a number of microservices. For example, our file integrity worker can scan a repository and then calculate a checksum, so SHA-512 and other checksums it can calculate. It also gathers file properties such as file size, ownership, permissions, and all of our microservices output JSON logs. So then we have the challenge of we merge all those JSON logs together for each file, and then those JSON logs are sent to our Elasticstack through Logstash. Then we use another microservice, which is our comparison worker, which compares the current scan so the current log file with the previous log file, and it can work out then all the differences between the two. So it can find fixity changes, permissions changes, ownership changes, all of those sorts of things. And it annotates the data of the scan, so we can then easily pick that up in statistics. So we then use Zabbix to gather those statistics on the annotations, and from Zabbix we then use Grafana to display that to the service owners. So each service owner gets their own Grafana dashboard, and they look at that for the high-level statistics, and then should they want to go into more detail of a statistic, they follow through into Kibana, which offers a secondary dashboard with much more detail. So it's quite confusing. You've got Grafana and Kibana, and so it takes a little bit of training when we have the new users start to get over all these terms. So I'll give you an example of the dashboard. So this is from our digital Bodleian service, which was taken from earlier this year. So this is Grafana. Hope you can see that. This is an example of a range of statistics available to the service owner, so storage size, various other bits. I haven't got time to go into all the details, but I would just want to show you basically the example of going into a statistic in detail. So one of them might be we project storage over 3 months, a year, and then 3 years. So that gives an idea to the service owner how big their repository is going to grow. So with digital Bodleian, in 3 years' time, we're expecting it's about 200 terabytes of data. You can then click through into Kibana, which is dynamic, so that runs on the fly. In a couple of seconds, it can show you a breakdown of all of the collections within digital Bodleian, the sizes and the storage used for each collection. So then we also started to introduce other deployments. So we have characterization service, again, uses Grafana for high-level statistics. And if you click through to, say, file format breakdown, it goes off to Kibana to give you some nice pie charts, and everyone likes pie charts. And again, service owners can customize these Kibana dashboards with extra filters. And so over time, they can create their own scenarios and their own reporting. So that's great. And we've got 2 more services to include. So we still need validation and preservation copy monitoring. So great. It's really good for us. We've got all this working. It's been running for 2 years. We've been fixing, checking all of this data. That's great. But what we want to think about now is moving this into more of a community version of the same sort of system. So we were thinking of a self-contained, scalable offering that would be useful to others, using similar open source tools, but packaged in a way that could be easily to configure and set up with just a simple interface. The idea would be maybe that it runs from a desktop in its smallest scale, so a Docker environment runs from a desktop, can scan your data, and it can then easily scale up to be multiple nodes for a much larger setup. So my question to the audience is, if anyone's interested in beta testing something like this, please let me know. I'll leave my contact details on the screen. I'd just like to thank Edith and Sebastian, who I think are in the audience, for their continued effort with this project. And yeah, come and talk to me at lunch or at the tea break.
Okay. Thank you very much, James. It was a really interesting concept, and just seeing the dashboard was really insightful too. So thank you very much. And you've heard James's call for a community around this as well. So please do come and see him if you're interested. Arif has a question already, so we'll go up to Arif.
Just one.
Yeah, multi-part though. But no, it's thanks very much for the presentation. Really interesting. But you can probably guess the question I'm going to ask you is that because the microservices kind of the architecture appears to be quite similar to, for example, something like Archivmetica. So I'm sure you've had your reasons to go with something completely different and custom built. But in principle, would it have been possible to build something on top of Archivmetica, because it already has a chain of microservices, it does the validation, fixity checks, everything. Of course, the logs are not produced in JSON, for example, but the logs are produced, but they could possibly be mapped onto something like JSON and then, integrated with reporting mechanisms, things like that. So I would just like to understand the kind of the thought process there. Thank you.
So yeah, we're quite happy with the current repository. So we have all sorts of different repository software. So we have Fedora and others, custom-built ones. The big problem with Archivematica at the moment is you can't, well, you might be able to now, but at the time in 2018, you can't just have Archivematica as a layer on top of existing storage. It has to go through this process of ingesting the files and then putting them maybe into different places of storage before they can be characterized and that sort of thing. What we wanted to do is leave everything in place with the existing repositories and have it just as a secondary layer that goes in, does all those calculations and extracts the properties of all the files, but doesn't touch the files in their repositories because we already have them in resilient storage, they're all fine, and we didn't want to have the extra effort of sort of migrating the content into yet another system. But we do actually use Archivematica in one of those repositories, so Beam, which deals with the digital-born archives. They're in a position where they want to ingest content, so they have a raw hard drive that they want to go through that process, which Archivematica is perfect for. So it goes through extracting, building into an unextracted archival package. Our microservices can come in then and carry out additional checks. So it can do the characterization again with different tools, can do virus scanning with Sophos, and it can do validation with other tools like JPalyzer. And then our reporting, we find, is more useful than what Archivematica offers at the moment.
Okay, so we're here.
I may have missed this, but are you running this entirely on local infrastructure? How frequently are the microservices running, and have you considered the carbon impact?
Yeah, so at the moment, all of our storage is local, so it's across different sites, but our virtual infrastructure allows us to connect to those storage services. We do want to move into the cloud, so other parts of the university have cloud storage. So again, we'd like to have a cloud node that does a similar thing, runs those microservices in the cloud, and then sends the reports back to our central hub, basically. Sorry, what was the second part of the question? So for file integrity, we scan it every month. So we scan 300 terabytes of data every month, and obviously storage is growing, and obviously you might not be able to do that as often. And then for characterization, we still run that every month at the moment, but obviously you only need to run it for files that have been added to the repository since the last scan. So we use some of the previous scans, so like the file integrity scan, to tell us what's been added, to then work out what else we need to scan. And things with characterization tend to be more, that it's not a regular, it doesn't need to be so regular, the checking, because it's more to do with reporting. So maybe at the end of the year you want to know what your repository looks like. It's not where you don't need to know everything about the files all the time. And carbon footprint of running this, we haven't really considered that. I mean, yeah, something we should do, as previously, I think was it Archivum was talking about the carbon footprint of this calculations all the time.
Okay, I can see Viv's got his hand up just over here, please.
Viv Cossey, Gloucester Archives. Thank you very much for your presentation, James.
Can you hear Viv okay up there?
I can't, yeah. Is
Yeah.
it on?
Is the mic on?
Right. Viv Cossey, Gloucester Archives. Thanks very much for your presentation, James. The slide that you showed revealed 44 fixity errors. Why did they occur, and what did you do to recover?
So let's go back to that. Yeah, again, I didn't have time to go. It would have been really interesting to go through in a bit more of a deep dive of these statistics. So you can see we have 44 fixity errors. So this is where it's calculated a checksum, and then on the previous scan, the checksum was different. So what we do in that case is it's still a little bit of a manual process. So what we would do is we send the service owner a GitLab ticket to say you've got 44 files that have changed. They go into the Grafana dashboard. They click through to the fixity link. If you can see just about, there's a little icon eye. When you click the eye, it gives you some details and a click through to Grafana, which then gives them a listing which they can download as a CSV file. and they go off and then look at those files. In the case of digital Bodleian, unfortunately, it's quite common, and it's to do with the metadata files. They go in and manually edit some of the XML files. And so what we do is we have a process of, we send them the report at the end of the month. They go through and say, yes, these are all the files we have changed, and then we can clear that for the next scan. And so so it's sort of like we have a communication with all the service owners, and we use GitLab in order to track those. So we can sort of build a history of what normally happens in your repository. So that's why, yeah.
We've got time, I think, for maybe one more question. Is there anything online, Samaya?
There's a comment from online. So Andy Jackson from the British Library says, the idea is very similar to something that they've been working on, or they've been building internally at the UK Web Archive. So yes, they're interested in collaborating.
Yeah, that's great. Like I was saying, just get in touch with us. We haven't got anything in place at the moment, but all the sort of core elements are there. We just need to package it up and make it a little bit simpler. And the idea is that we'd make it to be very small scale to start with. So it could run from a desktop mounted storage. And then maybe we can expand it if we get interest into cloud storage and other elements and scale it up. So yeah, thank you everyone.
Thank you very much. Can we say thank you again to James?